All right, AP Calculus. So here's our first video. I'm going to go through the 2019 test from last year, hence 2019. Probably 6 different videos, one for each problem, which is totally fine. If you have not attempted these problems at all yet, you need to stop watching right now. Stop, exit out, leave, come back after you've tried these. If you just watch me doing them, you're not learning anything. You need to have done these first. Make sure that you've done them. So if you haven't, goodbye. I'll see you after you've done them. All right. Now that we've gotten rid of the riffraff. The first problem talked about fish entering a lake. That's what the E of T is. That's the rate at which fish enter the lake. The problem should be in front of you. If you've got it, go to the website. You can go to Google and just search 2019 AP Calculus for your response, and you'll be given the link to those pages. I also sent out that link on a previous video, the first video that I created for everybody, or for calculus. So make sure that you are there, you have done the problems, and you have the problem in front of you, because I'm not putting the whole problem up there. So we have fish entering a lake at a rate of E of T, and they're leaving the lake at a rate of L of T. E for entering, L for leaving. They're both measured in fish per hour according to the problem, and T is measured in hours since midnight. And so we're going to roll through these questions that they're looking for. Part A, how many fish enter the lake over the 5-hour period from midnight, time equals 0, to 5 a.m., time equals 5, and give your answer to the nearest whole number. So this is a very popular question on the AP test. If we were in a normal AP testing time, if we weren't in this crisis that we're currently in, this would be a problem that I would tell you 100% for certainty will be on the AP test in some fashion. In this case, it's fish entering and leaving a lake. They've done problems where snow is falling and somebody's shoveling that snow. So snow is entering the driveway and leaving the driveway. We've had sand wash on a beach and being added to the beach at the same time. We've had water flowing into a pipe and water flowing out of a pipe through a hole. Every year, the AP test creates a problem like this. So I don't know what this year's test looks like. It's 45 minutes. It's all free. I'm assuming it'll be 3 free response questions of 15 minutes apiece, making that 45-minute time frame. There is no multiple choice, so I'm pretty confident in that. This problem, I would assume, is one of the problems that would be there. This is a very standard problem, and it does cover a lot of the calculus stuff. So I would plan on a problem like this. So this is one we definitely want to pay attention to. So anytime you're given a rate, and you're always given these rates in this type of problem, this is what we would call a related rate problem. And I know related rate, ooh, that's scary, but that's not kind of how these problems go. This is just they're giving us the rate at which something is happening. Something is entering and something's leaving, in this case fish. If you have the rate and you want to know how much, you just integrate. That's always the way that it is. And so we are simply going to integrate the E of T equation, because that's the equation that we use to determine the rate at which fish are entering the lake. We're going to integrate that. We want to know from midnight. So midnight is time equals 0 to time equals 5 a.m., which would be T equals 5. Okay. Notice it's E of T times dt. If we look at units, E of T would be measured in fish per hour, and then dt is measured in hours. If we multiply those two together, fish per hour times hours gives us fish, which is exactly what we want. So the math is supporting everything that we think that it should. So it's a calculator problem. I'm not sure how the AP test is going to go. I'm kind of assuming, since they're only doing a 45-minute section, that they'll do one calculator question and 2 non. But I don't know. They haven't given us that information yet. When they do, we'll figure that out. But this is definitely a calculator problem. You do not want to integrate this by hand. I've seen many students go ahead and start integrating this by hand and get it majorly wrong. Don't. You have a calculator. For anything you have a calculator for, let your calculator do all the work. You simply just punch this up on your calculator and you should get 153 fish. Make sure you give units. It's a word problem. All word problems need units every single time. There's part A. Now, for part A, remember, all AP questions are worth 9 points apiece. And so the points that you would get here, you would get 1 point for saying, hey, I'm integrating E of T, and then 1 point for the right answer with units. That's 2 very, very easy points that we have to have in doing this problem. Part B. Part B is asking us what is the average number of fish that leave the lake over the 5-hour period. That sounds like average value. If you recall our average value formula, average value is 1 over b minus a, so 1 over 5 minus 0, because they gave us those times the integral. In this case, we want to know the average fish that leave over that 5-hour period, and so instead of integrating E of t, we'll integrate L of t. Again, if we look at units, just to do this quickly, L of t is in fish per hour. dt is measured in hours, and so if we multiply those, this entire integral will give us fish. But they're asking us what is the average number of fish that leave the lake per hour. Well, that per hour comes from this. 5 minus 0, that's also in hours. So the integral gives us fish. That's 1 divided by hours. So we end up putting those together and getting fish per hour, exactly what the problem is asking us to find. Again, you're not going to do any work on this by hand. You're simply going to grab your calculator. You're going to use the L of t equation. Do not try and integrate this. That is not something you want to integrate. It's got this t squared up here. You're not going to have success integrating it by hand. Don't do it. Your calculator is there for a reason. Let your calculator do the work, and you should end up getting 6 fish per hour. Make sure you get the right units in there as well. The problem's telling you what the units are. If you go back to part B, what is the average number of fish that leave the lake per hour? They're telling you what the units are. Make sure you get those units there. This, again, just like the part A, is worth another 2 points. 1 point for having the correct thing to integrate, and then 1 point for the right answer with the appropriate units. Again, that's 2 easy points. You've got to have those points. Anybody can do those points. If you spent the entire year working through this calculus stuff, and we'll see, I'm going to do more videos on the 2018, 2017 test. You're going to see problems very similar to this. You're going to see a lot of patterns here. This is what we would be doing in class. Unfortunately, we're not there together. Doesn't mean we still can't do it and still can't pay attention to those things. So definitely get part A and part B. That's 50%. It used to be 50% would pass the test. I don't know what this year looks like. We're still going to bank on that. So make sure you get those points. Those are easy, easy points. Part C, at what time is the greatest number of fish in the lake? Justify your answer. So we're looking for something greatest. Greatest, that sounds like a maximum. We know how to find the maximum. Remember the steps. We take a derivative. We set it equal to 0 where it doesn't exist. We make a number line chart, right? All of that stuff that we learned back in first semester, it applies right here. You're looking for the greatest number of fish. But I don't have an equation that tells me how many fish I have in the lake at any time. So I need to create that equation first. So I'm going to create this equation. I'm going to call it A for the amount of fish. If I want to know the amount of fish that are in the lake at any point in time, I simply can integrate how many fish are entering the lake. So I'll integrate that from 0 to x, the E of t equation. And then I will subtract from that the amount of fish that would leave the lake. The amount of fish would be the integral of L of t. And then technically there's one more thing we have to add on to this. There might have been fish in the lake in the beginning. It doesn't say whether there are or aren't any fish in the lake in the beginning. I'm going to assume that there are, and so I'm going to tack onto this the number of fish that are currently in the lake, and so I'm going to call that C. That's just a constant. It's how many fish there are in the lake. It actually doesn't matter that we don't know that value, because once we have this equation, we're ready to do our process. Once again, this equation came from figuring out how many fish are entering the lake. That's this. How many fish are leaving the lake at that same time? That's this. And then how many fish did we start with? That's this. That would give us the amount of fish in the lake at any given time. I don't need to calculate the amount of fish. I need to calculate when that's a maximum. So to find that maximum, the first thing we need to do is we need to take the derivative. And so this derivative is going to be dA dx. I'm just going to write it as A prime though. But I need the right marker. And A prime. If I take the derivative, I'm going to be using the fundamental theorem of calculus. I'm technically going to be doing the derivative of the integral. Those are going to cancel each other out. It starts at a constant. It ends at just x. We know how to deal with that. Fundamental theorem of calculus says that that is simply going to be e of x, right? The variable changes when you're doing the fundamental theorem of calculus. If it ended at x squared, we'd have a chain rule. It doesn't, so we're good to go. Same thing's going to happen with the next integral. When we take that derivative, that's just going to be L of x. And then this is why it doesn't matter if we have any fish in the lake or not. That is a constant, and when we do the derivative of that constant, it's 0. And so here's our derivative. We're good to go. The next step when we find a maximum or minimum is to set that thing equal to 0 or does not exist. As far as does not exist is concerned, if you look at the equations, the sign is always going to exist, so that's always going to be good. This will also always exist. You can always raise 2 to any number and add 4 to it. So there's no does not exist happening, so we just have to look at when this thing equals 0. You can do this on your calculator, and this is what you should do. What I would do, you could punch this as one graph and see where it crosses the x-axis, or you could add L of x to both sides, graph these two things individually on your calculator, and see where they intersect. Either way, you should get one value. We get x equals 6.2 hours. we want to make sure that this is a maximum. I don't know that that's a maximum yet. We should look at that and make sure that we use our number line chart. So 6.2 is here. If we plug in a value less than 6.2, if you look at the graphs, e of x is on top of L of x when we're less than 6.2. So that means that the derivative a prime would be positive because e of x is bigger than L of x, less than 6.2. E of x is less than L of x when x is greater than 6.2. And so this verifies that we have a maximum. Positive means we're increasing, negative means we're decreasing. That creates a maximum. So, part C, at what time is the greatest number of fish in the lake a maximum, and justify your answer. And so our answer for part C is going to be we have a maximum at 6.2 hours. And then we need the reason, we need to justify our answer. And so our justification, we can say, because we've defined A, so I can just say A prime changes from positive to negative. There's our justification. Points. This is worth 3 points. Those point values come from, first, 1 point for recognizing that we need something, whether it's e of x minus L of x equals 0, or the fact that e of x and L of x have to be equal. 1 point for coming up with the 6.2 hours, and then 1 point for our reasoning or our rationale. Those points are pretty easy. It's just a maximum. We spend plenty of time doing maximums and minimums. We should be able to get those points as well. So now I'm looking at, out of 7 points here, we can easily have 7 out of 7 if you practice all of the years that I'm going to give you of practice, 2019, 18, 17. We will see these enough that this is not going to be that big of a deal getting those 7 points. Finally, part D. Part D is asking us, is the rate of change of fish in the lake increasing or decreasing at 5? And so we want to know if the rate is increasing. Well, if we want to determine if something's increasing, we want to look at the derivative. So I'm going to look at E prime, not E. I know E is the rate, but I want to know if the rate is increasing or decreasing. So I'm going to look at both E prime and L prime. Both at 5, because that's what the problem's asking us for. If you use your calculator, again, and you should always be using your calculator, E prime of 5 is negative 6.8. L prime of 5 is 3.92. If we go back to part C, we would be subtracting those, E of x minus L of x, or E of t minus L of t. And so if I subtract those, E prime of t minus L prime of t is a negative value. It's negative 10.72. A negative value tells us that the rate is decreasing. And so the rate is decreasing because E prime of t minus L prime of t is negative. This is your final 2 points. Those 2 points come from number 1, realizing that you need to be looking at E prime and L prime, and then 1 point for your reasoning of why your answer is what it is. There's your 9 points. I think these 9 points are doable. Look forward to the next video. The next video is going to work on problem number 2.